Okay, let's talk about tooling today. I think that's what this chapter is all about. Let me just turn on. What? Haha. Okay, it's okay. I'll use this. All right. Okay. All right. I'm just trying to get myself oriented. Mouse, pen, things like that. Okay. Creating small tools. Let's do one thing and do it well. It's all about picking the right tool for the right job. Totally agree. So every operating system includes small tools. Small tools written in C perform specialized small tasks, such as reading and writing files or filtering data. If you want to perform more complex tasks, you can even link several tools together. But how are these small tools built? In this chapter, you'll look at the building blocks of creating small tools. You'll learn how to control command line options, how to manage streams of information and redirection, and getting tooled up in no time. So small tools can solve big problems. So this, one philosophy for Unix or any Linux-based system is to create small tools. Basically, a tool should do one thing and do it well, and also provide a mechanism where it can be receiving standard in, like any input as text, and then output as text, where you can actually like start chaining them together or like connecting them as pipes. That's where you get the whole piping from. So like for example, if uh, I did something like echo hello, right? I can actually pipe that and maybe do grep L, and then it'll actually echo hello will output hello, take that result and put it in as input to grep, right, to find any matches with EL. And then that output can be displayed on the terminal, or you can even throw it into a file, right? So that's what these small tools are for. It makes it so that you can actually take these small tools, put them together to create like a bigger tool underneath the hood with like a shell script or something like that. So a small tool is a C program that does one task and does it well. It might display the contents of a file on a screen or list the processes running on the computer. So yeah, most operating systems, right, like Linux, it comes with a bunch of tools. I think the place where that is it like, is it USR bin? Yeah, something like this. USR bin, maybe. Let's see. Wherever LS is, let's see. Which LS? USR bin, right? So USR bin has a bunch of the tools that we use every single day. For example, we have um, LS, right? LS here, and maybe like some stuff like cat too. Cat, we like using cat, so we find cat. I don't even know what's the best way to scroll up or look for stuff. Oh, I know. So CP, right? And then maybe cat right here. So yeah, it comes with a lot of tools. I should have done this. Let's see. Can we do ls pipe grep cat? Oh no, I guess not. So yeah, um, these small tools usually not just OSs that include them, right? You can download them as like maybe a suite of packages. But yeah, generally you would run them through like a terminal or something like that. So, and then that's the whole thing about C is that you're creating these little small terminal based programs, and then uh, just hopefully in the future reusing them for some other bigger program. Let's see. Hmm. All right, so let's continue. So the book is saying that there's like a text file here that has like longitude and latitude, right, along with speed. It's coming in as like a CSV, and basically we want to kind of write a tool that turns it into like a JSON format right here. Okay, so given this file, turn it into a file that, or maybe output that emits a JSON like object. So yeah, just basically, um, yeah. Here's another exercise. So hey, who hasn't taken a code printout on a long ride only to find that it soon becomes unreadable? Sure, we all have, but with a little thought, you should be able to piece together the original version of some code. So this program reads the CSV from the command line and displays it in JSON format. So let's try to fill out this missing code, okay? So this is actually like a CSV parser from the command line. And so we want to take in a number, and then what is this? Give me every character up to the end of the line. So about 79 characters because the buffer is 80 characters, and we don't want to consider the last null terminating character in this case. Okay. Now, what we want to do is we're going to probably pass in the addresses of these pointers. And then, what does this thing? Returns the number of values it was able to read. Is that what scanf does? The return value of scanf returns the number of values it was able to read. So basically, while we're able to always read 3 values in, we do our conversion right here, right? So started, what is started? How you set started? Is this, so we'll print, basically, if started is, I guess, truthy, we'll output a new line. Otherwise, we'll output, or otherwise we'll set this as what? As false, which is 0. And then we'll print our values here. So we'll print whatever the user supplied. So basically whatever latitude, longitude, and the information was. So start with new line, and then we keep doing that, and it will print out. Oh, I see. So this is going to inject a new line after every JSON entry. Okay, and we don't want, so this flag is only used once, it seems. So what it does is it's just going to add a comma after every entry here. That's really about it. That's all it does. Okay, let's try to program that. Huh. But yeah, so we'll print out this JSON here. You notice the curly braces? And then notice how like we print out the data here, the array, the start of the array, and then we end the array here with a new line. So yeah. Let's just fill in the code. So we'll call this lat long CSV to JSON. Lat long CSV to JSON. And then, oh, that's a file. Okay, lat long CSV to JSON. And then we'll create a file, main.c, as always. Then we're going to start a template. Okay, now it's easy. We'll just copy most of this. And I prefer to copy because it's going to help us with syntax, right? So int main. I'm just going to copy exactly the way it is. Float latitude, float longitude, character, let's do this, character info, 80 characters. So 80 character buffer. And then like a flag that says start, that we call started. And I'm going to say it's going to be It's going to be starting at 0, so false by default, false-y. And then we're going to put data. And then we're going to have a loop that asks the user with scanf for 3 different inputs. So comma 79. This is a very interesting way to ask all the way up to new line. So we're going to exclude the new line from input. And then second parameter are our memory addresses. So the address of, looks like latitude, the address of longitude, and then, info. So the address of info, it's an array, so we don't need to get the address. It's already automatically seen as like an address. Okay. And then, equals 3. So basically, when we receive 3 inputs from the user, I kind of want to see something. I want to see what actually scanf returns with man, so that it's for my own reference, because I didn't know it returned a number. So here we go. Oops. Let's see. So scanf. Okay, description. I don't want description. I want return value. On success, these functions return the number of input items successfully matched and assigned. This can be fewer than provided for, or even 0 in the event of an early matching failure. Okay, so that's why we have to explicitly check for 3 user inputs. So makes sense now. So scanf float string 3. Okay. Now, hey, is my tab finally 2 spaces? That fixed itself. That's so cool. Okay, sure. If started. Again, I like braces in my if statements. Printf new line. Otherwise, set started to 1. Okay, so that means every time. So it's only after the first time we start adding a comma and a new line like this. All right, it's only after. So we don't add a comma and a new line before. So I think that's what it's saying. So printf. We're gonna print the little JSON that we're building. It doesn't really look JSON because JSON actually has quotes, but we'll fix this after. Latitude F, longitude F, info will be a string. And then our format here would be, and remember, we want to print all this out to a screen, to our terminal. Okay, so that's where we'll print F. We'll do print F. And then put S, we want to still output to terminal, but we don't have any formatting to be done. Oh, geez, it's annoying. So, again, latitude, longitude, and info. Cool. Okay, so I kind of want to fix this because this is not really JSON. JSON has quotes around the key. So I'm going to add some escaped quotes so that it appears. So I'm going to do backslash quote here. Backslash quote there. Same thing with longitude. And same thing with info. That feels more like JSON. Oh yeah, and info should have quotes too. Yeah, we need to wrap quotes around strings. Okay, that feels better. And then we'll put, let's see. We'll put with a new line and an end array. Why is it? There we go. Okay, then we'll return 0. And another thing is that this is actually not valid JSON. It's to have like data equals whatever. So let's get rid of that. We want like a clean JSON. I would even say like we should. Yeah, that's fine. Yeah, so that's some clean JSON right there. We have quotes, around where quotes should be, right? And then we also have an array, which is valid JSON. So let's test it. So let's do let's go into our C folder, go into lat long csv2json, and let's compile our program and let's run it. So now it's expecting, was supposed to expect user input, but I think oh yeah, that's true. Okay, that's really weird. It's printing this first, but okay. Let's see. Oh, it's doing a direct conversion. Okay, so I don't know. I don't know. Let's do 2, 3, and then how do I input it as a string? Hello there, like that. How come it didn't print F? Was it because I didn't provide input, or oh, I had to provide? I'm asking for it to look like this, not with spaces. I see. So I had to input it correctly. That's why the while loop didn't run. So it probably only read one input. Okay. Okay. So let's try again. 2, 3, comma, like the same format as this, and then maybe just hello there. Haha, exactly. So yeah, literally, I learned something new today about scanf. Is that this is the format it expects, exactly the format. It's not like white space or anything like that. It's this is when you specify scanf to accept something in this format, like the user has to actually uh just input it in that way too. So that's how it actually is able to read in 3. So interesting. Let's see how we did. So inst. Okay, let's compare. So yeah, int start is 0, and then start is converted to 1. Okay, and then we have the address, latitude, longitude, and then info. And then we printed it out just with the values, latitude, longitude, and info. Right? And remember, this is basically a pointer, so that's why we don't need to dereference it. Okay, cool. Yeah, see, you don't need the ampersand here because printf is using the values, not the addresses of the numbers. Did you remember to pass the address on the number variables? Yep, because scanf needs pointers. And here you go. You'll display a comma only if you've already displayed a previous line. Once the loop has started, you can set started to 1, which is true. Yeah, so remember, in C, there's no boolean. It's either, falsy value being 0 or truthy value being a non-zero. I could have set this to 2, too. I think it would have been fine. Let's try it. I should have set it to 1, 2, 3. Yeah, let's set it to 1, 2, 3. And then it'll still work the same way. 1, 2. Hello, world. Yeah, it'll still work the same way. I think. Yeah. So let's do this. 3, or yeah, 2, 3. Bye. There you go. You see that comma? Yeah. So, all right. So yeah, it's supposed to look like this. How the comma is bottom right here. But yeah, it looks ugly, right? That's what they're saying. The program lets you enter the GPS data at the keyboard, and then it displays the JSON format data. So yeah, it was expected that the square bracket would come up right here. So the problem is the input and the output are all mixed up together. Also, there's a lot of data. If you're writing a small tool, you don't want to type in the data. If you want to get large amounts of data by reading a file. So how is the JSON data going to be used? Surely it can't be much use on the screen. So is the program running okay? Is it doing the right thing? Do you need to change the code? I argue maybe not. we don't want the output on the screen. We need it in a file so we can use it with the mapping application. Here, let me show you. Okay, they're going to teach us something really cool. So here's how the program should work. So basically, you want to take the GPS data, you want to generate that CSV, right? Then you take in that, so you have your program here, which is expecting this CSV file to come in as input, right? And it's going to be read line for line. Then after that, as your program will convert everything to a JSON string, and then output that into a JSON file. Then you can use this JSON file to do anything you want with it. And remember, JSON is very web-based, so you can actually create a UI to consume that JSON in like HTML or JavaScript. So that's cool. But yeah, the problem is that we're not using files. We're reading the data from the keyboard, right? So that's why everything's getting mixed up. We're expecting the user to type it all. So yeah, what we need to do is you need to make the program to work with files. But how do you do that? If you want to use files instead of the keyboard and the display, what code will you have to change? Will you have to change any code at all? So that's a hint, okay? So again, think about it. Is there a way of making our program use files without changing any code, even without recompiling it? So as it is right now, our program is good, okay? And we're not going to recompile. We're not going to touch it. We're just gonna do some interesting tricks to be able to read from a file and then output to file. So read into CSV and then output into a JSON. So let's read this. Also, these are just tools. I'll skip over that. You guys can read this on your own. Okay, so you could use redirection. You're using scanf and printf to read from the keyboard and write to the display. But the truth is, they don't talk directly to the keyboard and display. Instead, they use the standard input and standard output. So the standard input and standard output are created by the operating system when the program runs. So standard input is like any sort of common interface to receive input for your program. Standard output is any common interface implemented or anything that implements a common interface to output data from your program. I don't know if this is like a good diagram, but sure. So the operating system controls how data gets into and out of the standard input and output. If you run a program from the command prompt or terminal, the operating system will send all of the keystrokes from the keyboard into the standard input. If the operating system reads any data from the standard output, by default, it will send that data to the display. So that's the default behavior, right? So the default standard input behavior is to expect keyboard input, and the default behavior of standard output is to just shoot things to the display. The scanf and printf functions don't know or care where the data comes from or goes to. They just read and write standard input and standard output. So yeah, it's kind of hard to grasp right now, but I think the best way I can imagine it is that scanf and printf don't really care about what the device is, like the physical thing is. It's as long as that device implements like kind of like a driver, like an interface that is common amongst all other, like for example, you have like a standard, some sort of input taking device, right? Like a keyboard or maybe a camera or whatever. They're probably going to implement like a standard set of functions that the operating system would just blindly call. And then basically, as long as they return some sort of data from calling these functions, we can use that and pass it into any program, right? Same thing with the output, right? Any like screen or like printer or whatever, they'll probably implement like a common set of functions that the operating system will call, like an interface, and then shoot out some data, right? It's expected that the printer will shoot out some data. The not keyboard, the display will shoot out some data and so forth. So this might sound like it's complicated. After all, why not just have your program talk directly to the keyboard and screen? Wouldn't that be simpler? Well, there's a very good reason why operating systems communicate with programs using the standard input and the standard output. You can redirect the standard input and the standard output so that they read and write data somewhere else, such as to from files. So you can use the redirection operator. So remember, the redirection operator is like, some program, right? And then you can redirect with this angle bracket to somewhere else. And usually we'll do that to like output to a file. But you can also input by using the opposite way, so somewhere else. Then that will actually turn this into standard input. So taking somewhere else, some file from somewhere else, and then just jamming it into your program as standard in. So yeah, so right here, you can redirect the standard input with this angle bracket going left, I guess. Instead of entering data at the keyboard, you can use the angle bracket going left operator to read the data from files. So this is all done during the terminal, inside the terminal, right? So let's actually do this. Let's create a file, and I'll just create it here. Let's say j.csv with vim, and then I'm just going to copy and paste this way, and then I'm gonna right quit. Wait, actually, let me get rid of this line. Then I'm gonna right quit, and then I'm gonna use this and call it the way they're doing it with the CSV as input to our program, right? So let's do it. Let's see what our program outputs now, because everything is just not coming in from the keyboard anymore, where it's obligated to kind of show up in our terminal, right? But now it's going to be passively ingested through a file. So if I did a.out using standard in, redirect, right, with data.csv, so our current directory, right, with data CSV, we'll actually get the JSON. That's pretty cool, right? So the I guess going left angle bracket operator tells the operating system that the standard input of the program should be connected to the GPS data.csv. In this case, ours is called data.csv file instead of the keyboard. So you can send the program data from a file. Now you just need to redirect its output. So now we have our output in our terminal, right? But that's still not ideal, because the requirement was that, I think this guy said something here interesting. He said, we need it in a file so we can use it. So they want to also use the data too. So outputting to a file makes sense. So yeah, we can also redirect output from the terminal to somewhere else with the angle bracket pointing right. Right. So yeah. So the same thing is like, instead of now all this is going to go to a file if we probably run it like this. So let's see, a.out, and I'm just going to maximize this. We have a.out. We're going to bring in data.csv, and then we're going to redirect the output to output.json. Okay, so nothing happens. Why? Because we've redirected all the outputs somewhere else, not the screen this time. The screen doesn't handle the output anymore. So we did lsla. We have a JSON here that's about 1 kilobyte, and let's actually see what that is. Looks like it's our JSON file, right? So let's see if it's even valid JSON. If we can open it in VS Code, we'll see it too. So it looks like it is valid JSON. And we can even do stuff in our text editor by formatting it, for example, like this. So we have valid JSON. So we're taking the CSV here, then we're going to convert it to JSON. That's what our program does. We didn't need to change our program. We didn't even need to we didn't need to recompile it. We just ran it just by doing some redirection. So they have a sample here that you can try. Given some JSON, you can actually I guess render out points here. I wonder if this still works. Nope, it's down. So whatever. Whatever. I think for web developers out there, this is probably the obvious part. Is just it's like consuming a API result, right? Okay. So yeah, there's a problem with some of the data. Your program seems to be able to read GPS data and format it correctly for the mapping application. After a few days, a problem creeps in. So the problem, if you have a hard time seeing, but it's basically saying invalid latitude 423.631805. So basically, there's an error in the CSV and the number is way too big. It's not even a valid latitude. So what happened here? The problem is that there was some bad data in the GPS data file. So there was like this occurrence right here. I think we don't have it, but we could definitely add it. Let's add it. Let's add this to our CSV. So let's just use Visual Studio Code and add it there. So let's go to our data CSV and let's add this. Okay. And then let's use our program again to get the JSON version. Okay. And now at this point, we should have it here in JSON. Cool. Okay. So we're at their pace now. So the Geo to JSON program doesn't do any checking of the data it reads. It just reformats the numbers and sends them to the output, right? So this program is not like responsible for actually doing the validation. It's only responsible for just taking in some input, reshaping it, and turning it to JSON. So how are we gonna solve this problem? I think we have a solution. We can use we can probably maybe create another small tool to do the filtering and then output maybe back to CSV and then feed it to our program. So yeah, we'll have like a filter step. So here's the exercise. Here's I guess the program that we need to modify. Well, it is the same program. I think they want us to modify it, right? So if the latitude is less than -90 or greater than 90, then error with the status 2. If the longitude is -180 or greater than 180, then error with the status 2. So we're going to use error code 2. And there's a reason why. Error code 2 is basically the code for standard error, I believe. And then I think regular standard out, like non-error related things, uh go to standard. Yeah, sorry, error code 0 goes to standard out. There we go. So, and we're not creating a new program. We're actually, turns out we're gonna modify the same program. So it's easy. It's just checking, right? So if latitude is -90 or latitude happens to be greater than 90, then we'll say invalid latitude. And let's give the some let's output the number. Actually, it'll be a float so that we know, or whoever reads the logs will know latitude, and then we'll return 2. And then and then if longitude is less than -180 or longitude is greater than 180, then again, invalid longitude, and it will output what that was. Okay, and we'll return 2. Oops. Okay. So Yeah, invalid latitude. That's exactly what we did. Okay, I swear I didn't even do this example before, so it's funny because software developers when we log and stuff like that, we tend to not write complete sentences. We're like speaking as if we had very limited language. So yeah, this is the right condition check. Now what do we do? Okay, so you now have the code in place to check the latitude and longitude, that the latitude and longitude are in range. But will it be enough to make our program cope with the bad data? Let's see. Compile the code and then run the bad data through the program. Okay, let's do it. No. Ugh. Okay. So GCC main.c, and then let's output to output.json. Okay. No error message, right? That's strange. So we got the same thing as them. We didn't get any error message. Huh. Well, WTF, no error message? Where did all the points go? Let's see. Let's look at our JSON. Whoa. Right here. We got an invalid latitude. That's interesting. So they got an error in their JSON too, which is why most likely they're not printing out any points. Right there. It's because we had an error message printed out, right? And it also went out to our output.json, because that's what it would have normally done, right? If we didn't redirect like this, it would have done this eventually on some iteration where it encounters this invalid piece of data. So once you open the file, you can see exactly what happened. The program saw that there was a problem with some of the data, and it exited right away. It didn't process any more data, and it did output an error message. The problem is because you were redirecting the standard output into the output.json, that meant you were also redirecting the error message. So the program ended silently. And you never saw what the problem was. Now you have checked the exit status of the program, but you really want to be able to see the error messages. So how can you still display error messages if you were redirecting the output? Let's see. Well, here's a fun fact. If your program finds a problem in the data, it exits with a status of 2. But how can you check that error status after the program has finished? Well, it depends on what operating system you're using. If you're running on a Mac, Linux, or some other kind of Unix machine, or if you're using Cygwin on a Windows machine, or Windows subsystem for Linux, you can display the error status like this. So just literally type echo $question mark, okay? Echo $question mark. 2. Okay? Both commands do the same thing. They display the number returned by the program when it has finished. So the latest error code. Wouldn't it be dreamy if there were a special output for errors so that I didn't have to mix my errors with the standard output? It's just a fantasy. No, it's not. We do have one. Standard error. Introducing the standard error. The standard output is a default way of outputting data from a program. But what if something exceptional happens, meaning like an error? You'll probably want to deal with things like error messages a little bit differently from the usual output. That's why the standard error was invented. The standard error is a second output that was created for sending error messages. Human beings generally have 2 ears and 1 mouth, but processes are wired a little differently. Okay, every process has 1 ear and 2 mouths. The standard output and the standard error. That's really weird. So let's see how the operating system sets this up. So by default, the standard error is sent to the display. Remember how when a new process is created, the operating system points the standard input at the keyboard and the standard output at the screen? Okay, that's by default, right? Well, the operating system creates the standard error at the same time, and like the standard output, the standard error is also sent to the display at default. So yeah, this is why we saw that. Output and error are both to the screen by default. That means if someone redirects the standard input and the standard output, so they use files, the standard error will continue to send the data to the display. Oh, that's cool. That's really cool because it means that even if the standard output is redirected somewhere else, by default, any messages sent down the standard error will still be visible on the screen. So what they're saying is that you can actually, instead of having both redirects, right, you can control one of them. And you can control the standard output to go to a file and keep the standard error going out to the display. Okay, so how do we do that? Well, fprintf will print to a data stream. So fprintf will actually allow us, instead of printf doing both standard output and standard error to the same place, I think fprintf will allow us to specify, right, what data stream we want to output this piece of text, this string. So fprintf prints to a data stream. You've already seen that printf function sends data to the standard output. But what you didn't know is that the printf function is just a version of a more general function called fprintf. Oh, so fprintf underneath the hood will just call fprintf with std out as an argument. That's interesting. The fprintf function allows you to choose where you want to send text to. You can tell fprintf to send JSON or to send text to std out or std error. Okay. There is a std out and std error. Is there a std in? Yeah, we've been using that one. It's a standard output, standard input. Can I print to standard input? No, it's just for input. Can I read from it? Yes. You can use fscanf. So specifically take from standard in. But we only have one stream, right? Or I guess a file stream cost is also counted as standard in. I guess, well, not a type of input. So if fscanf standard in is exactly the same as scanf, yes. Can I redirect the standard error? Yes. This angle bracket pointing to the right redirects the standard output, but the number 2 with the angle bracket pointing to the right redirects the standard error. But that's only if you specified it with fprintf, like only if you're, I guess, you're controlling the directions. So I could write csv2json to angle bracket to the right errors.txt. Yes. Okay, so let's update that code. So what they're doing now here is they are basically just, instead of printf, we're using fprintf. And I think by default, printf uses standard out, so we don't need to change this. We only need to change the places where we want to output to standard error. So we'll do that here. Wait, is this even the right? This is not even the right one. This one. Let's close this one. Yeah, fprintf, and then we'll say standard error, and then fprintf standard error. So something like this. So that will actually print invalid latitude and invalid longitude to standard error instead. Cool. Okay. So let's test drive this. So again, we do this. We'll get the input data from our file. and then we'll output all standard out things to a JSON, but we'll actually keep standard error coming out to the screen. So I think we have this. Yeah. So we did this. Oh, we didn't compile. GCC main.c. There we go. Cool. So we got SCD error coming out to the screen, which is what we wanted. So we should expect a clean output in our JSON. Did we? Did I leave something? Still, oh yeah, because it's still erroring. It's still erroring. It makes sense. So, okay. We have a reason to believe that the following program has been used in the transmission of secret messages. Oh, so this is like a little bonus problem. So I'll leave that to you to read. These are just like little exercises, which I think you should probably do. I mean, I'm not going to go as slow as the pointer stuff because this stuff is more straightforward. Um, should I go through this one? No, you probably should just read that. But, so it's like they left us hanging. What is this? Isn't that, well, I guess the requirement is that they shouldn't. It's not like they told us to skip it, right? It just told us to redirect standard error. But yeah, let's see what happens. Small tools are flexible. One of the great things about small tools is their flexibility. If you write a program that does one thing really well, chances are you will be able to use it in a lot of contexts. If you create a program that can search for text inside a file, say, then the chances are you going to find that a program. If you create a program that can search for a text inside a file, say, then chances are you that's find that program useful. I might be getting tired. Okay. For example, think about your Geo2json tool. You created it to help display cycling data, right? But there's no reason you can't use it for some other purpose, like investigating the Bermuda rectangle. Huh. Oh, so you change it. You change the limits here because it's now just scoped to a specific region. All right. So to see how flexible our tool is, let's use it for a completely different problem. Instead of just displaying data on a map, let's try to use it for something a little more complex. Say you want to read in a whole set of GPS data like before, but instead of displaying everything, let's just display the information that falls inside the Bermuda rectangle. So we'll have to adjust our program here. So where do you need to begin? I'm stopping right here.